So three-phase induction motor, basic part stator winding, rotor winding. Okay. Stator, it is a three-phase winding, either star connected or delta connected copper winding. Put inside the stator slots, you can see. Then this winding is covered with the outer frame of silicon steel for protection of winding. So this stator, it is assembled inside this frame. Then rotor either spiral cage or wound rotor. It is made up of good quality copper winding. Rotor itself having winding or rotor bars. So, and you are having the three-phase connection brought out, terminals brought out for purpose of connection. As far as rotor construction is there. You can have rotor construction, spiral cage rotor construction. So spiral cage rotor construction, here you are having the rotor shaft, end rings and rotor bars, skewed rotor bars. You already studied the construction. I am just explaining in brief. This is a stamping of rotor, provision for shaft, provision for rotor bar slots. Okay. Rotor winding may be either connected in star or in delta. Okay. Any doubt? You can ask if you have. Then you are having this another construction that we call it as a wound rotor. Or slip ring rotor. This is wound rotor. Wound rotor or slip ring rotor. Here you are having similar to the stator winding, rotor winding is provided, which is provided in rotor slot. Connections are brought out here at slip ring, and you may have connections either star or delta connected. So star connected stator, star connected rotor, or delta connected stator, delta connected rotor. Any doubt regarding this? It is limited as far as the behavior of motor is concerned. What happens under abnormal condition? What happens under different abnormal conditions to three-phase induction motor? So let us study. You know that major thing in induction motor, that is a torque, and especially we call it as a starting torque. So starting torque is equal to, we have the equation, starting torque is equal to constant K1 into voltage induced, that is E square of the voltage into resistance of the circuit, that is rotor resistance R2 divided by impedance Z2 square. So here you can see the EMF induced in secondary. In this formula you can see the EMF induced in E2 is E2 is EMF induced. So EMF induced E, that is proportional to EMF induced E, that is proportional to voltage applied, and therefore you can see that starting torque is proportional to voltage, because you are having in this equation काय काय तुमच्या इक्वेशन मध्ये K1 then R. Okay, are you with me? K1, then you are having R. Okay, this K1, you can see this K1. Okay, here I have mentioned. Then you are having this term R2. Then you are having this term Z. This is also Z2. So K1 R Z. These are constants. If you say then torque is proportional to E, so torque is proportional to only V, right? लक्षात येत आहे का? Torque is proportional to V square. So you can write equation the torque कुठला स्टार्क आहे? starting torque TST is proportional to काय लिहिता येईल आपल्याला? Starting torque is proportional to V square. Okay. So change in voltage we have mentioned here directly affects the starting star. So this you can explain. Another effect of supply voltage we have discussed. Now you can have the effect of change of voltage on current also. When the voltage is increased or decreased, suppose when voltage is increased, starting current increases and no load current also, because of the no load current also increases. Simple diagram you can see here. Effect change in voltage on power factor also. Okay. So when this change in voltage, motor is working on no load condition, supply voltage increases. This is supply voltage. This is no load current. This is a magnetizing current component IU. This is a core loss current component which is in phase with voltage. Magnetizing current component exactly 90 degree with voltage. And resultant no load current drawn by machine under normal condition is I0. Resultant of IW and IU. So this is a power factor angle phi 0 at no load. So this is cos phi 0. We called it as no load power factor. Cos. You can have equation here. Cos phi 0. That is no load power factor. So you can see when this supply voltage increases, IW increases. Okay. So no load current increases. If motor is working on no load, supply voltage increases, magnetizing current is also increases. And because of this हा वाढला, cos phi decreases. Okay, phi decreases. And on the other hand, supply voltage decreases and power factor increases. So the effect of particularly no load condition is also there because of change in voltage. Change in voltage also affects on the efficiency of machine. Okay, as we know that torque is directly proportional to V. So V decreases, efficiency decreases because of the decrease in torque. Then unbalanced voltage also, effect of unbalanced voltage. So whenever voltage changes, change in voltage in this chapter, in this particular table you can see what happens, what are the different terms get affected. Percentage change in voltage 10% increase, 10% decrease. Normally it has been observed current, starting current, magnetizing current and full load current. So when 10% increase in voltage, 10 to 12% starting current increases, magnetizing current increases and full load current decreases by 7 to 8%. When voltage decreases by 10%, starting current decreases by 10 to 12%, magnetizing current decreases and full load current increases. Then temperature rise also is there, change in voltage, decreases temperature by 3 to 4% when there is 10% increase in voltage, but decrease in voltage 10% increases temperature by 7%.